Welcome back to True North Mechatronics. With our mobility base and accessory deck locked in, it's time to tackle our odometry and our structural load paths. In this episode, we're engineering the pedestal mount. This pedestal is designed to rigidly secure our IR tachometers to track wheel rotation. This component also acts as a structural node. It anchors the vertical rail that will support the overhanging weight of our battery box. Design, engineer, deploy. Let's get into the CAD. Begin by creating a new body and a new sketch on the XY plane. We're going to grab the rectangle tool and we're going to create a rectangle that's symmetric around the origin. We're going to set the length of this to 94 millimeters and its vertical length is going to be 12 millimeters. Now we need 3 holes that we'll use for mounting this pedestal to our mobility base. So we're going to want to make sure that we're really careful and not let the edge of these holes touch the x-axis because FreeCAD will try to constrain it there as a tangent. We're going to make sure that these 2 outer holes are symmetric around the y-axis, and then we're going to make sure that these holes are also collinear with that central hole. All right, so let's set the diameter of all 3 of these holes so that they're equal, and then we will set the overall diameter to the minor diameter of our PT screws, which is 2.8 millimeters. Okay, so let's set the distance between these 2 outer holes. That's going to be 63 millimeters, and we're going to create an offset from the top of our rectangle of 7.5 millimeters. All right, with that, our shape is fully constrained and we can close out of this. And we're going to pad this out to 8 millimeters. All right, we need to create a shoulder on the top of this block. It will be used for securing the IR tachometers. So we're just going to reference the top edge of this block, and using the rectangle tool, we'll create a rectangle. We need to make sure that the edge is coincident in both corners, and we'll set the width of this shoulder feature to 4 millimeters. So with that, our shape is fully constrained. We can close that, and we're going to pad this out to 7 millimeters. Now that we've got that done, we're going to look at the back of this shape, and we're going to add 2 sets of holes. These will hold the IR tachometers onto our pedestal mount. So create 4 holes, and we're going to make sure that the outer 2 holes are symmetric around the y-axis. The inner 2 holes will be symmetric around the y-axis, and then we'll make sure that these 2 sets of holes are collinear with each other, so they should move as a set. Let's make sure that the diameters of all 4 of these holes are equal. And we will set the diameter to 3.2 millimeters. We're using 3 millimeter bolts to hold the tachometers onto the pedestal, and so we need to leave a little bit of room in order to have some clearance for those bolts. All right, so let's set the distance between these 2 inside holes to 18 millimeters, and we'll set the distance between the 2 outside holes to 60 millimeters. So there's our holes. The last thing that we need to do is we need to set their location in relation to the top of our pedestal here. So let's set that distance to 3 millimeters. And now we can see that our holes are fully constrained, and we can close out of the Sketcher workbench, and we're going to pocket those through. And 5 is greater than the 4 millimeter thickness of our shoulder, so we're good. And now we're going to create some clearance pockets on the back of our pedestal mount here. The IR tachometers have through-hole components, and the ends of the pins protrude past the back of the circuit board. So we have to clear away some of the material here in order to not put tension on the circuit board of the IR tachometers when they're being secured. So let's set the horizontal length of both pockets so they're equal. We'll do the same thing with the vertical length, and we're going to make it so that these are symmetric with respect to the y-axis. So let's set their horizontal length to 13.5 millimeters Their vertical length is 5.75 millimeters. And let's set the distance between them to 25.5 millimeters. All right, so with that, those clearance pockets are fully constrained, and we're going to set the pocket depth to 2.3 millimeters. Next thing that we're going to do is we're going to add 2 mounting holes to this pedestal mount. This is where the vertical rail will be connected that we construct in the next episode. And this vertical rail will support the overhanging battery box. As before, we need to make sure the diameters of both of these holes are identical. And we're going to set these to the minor diameter of the PT screws. That's how we're going to secure the vertical frame rail to the pedestal mount here. And let's set the distance between these holes to 39 millimeters. And we're going to set their offset from the bottom of the pedestal at 4 millimeters. All right, so those holes are fully constrained, so we can close out of the Sketcher workbench, and we're going to pocket those all the way through. That's a 12 millimeter thickness, so 12 millimeters, we'll pocket them all the way through. Now, the last thing that we need to do is we need to add a feature onto the pedestal mount. It's a deflection buttress is what it is, and what it'll do is it will eliminate deflection in the mobility base between the pedestal mount here and the accessory deck that we created in the last episode. So we're going to make this symmetric around the y-axis, and we'll set its thickness to 7 millimeters. So there we are. That's fully constrained. We can close out of that, and we're going to pocket this out to 8 millimeters. And the last thing that we're going to do is we're just going to add some decorative fillets. It removes a small amount of plastic from the edge, but also gets rid of some sharp corners on this part. So 6 millimeters is fine. Let's close out of that. And with that, we have completed the pedestal mount. We now have a stable foundation for our odometry sensors, and we have a rigid structural anchor point ready to take the load of our battery module. In the next video, we will engineer the vertical frame rail. We're pulling inspiration from the vertical frame rails created for the TitanBot fleet, and this will help to manage the overhanging load of the battery. Chart your course, build your world. See you in the next one.